All right, we're going to talk about things like WPSs, PQRs, certifications, qualifications. We're going to discuss how to weld one to be able to pass. We're going to discuss, what different things would cause a plate to fail, how to prevent them. Some things you can get away with, some things you can't get away with, and sometimes it all just depends on the CWI that's going to check it. So starting out, what's the difference between a certification and a qualification? A certification is done through the AWS, the American Welding Society. Okay, it is a plate, it's not a written test, it's just simply a plate that gets welded, and it is checked by an AWS, an ATF, an accredited testing facility. Okay, there'll be checking for discontinuities, but they also, what kind of separates really from a certification versus qualification is paperwork, being able to track from start to finish. At one time I ran an ATF, we had to document where we got the plates from, the chemical composition of the plates, the filler rods. We had to keep track of the filler rods. They could not just simply sit out in a rod oven where anybody would be able to grab them, because then we did not know how long they were out of the oven, if they went back in the oven, how long, because there are codes that state all these things. So it was a lot of documentation, which really is what it comes down to. There are a few things as a welder that on the backside you also have to do. A certification is good. Basically it states that the period of effectiveness that a welder or a welder operator qualification as specified in this code shall be considered as remaining in effect indefinitely unless 1, the welder is not engaged in a given process of welding for which the welder is or welder operator is qualified for a period extending 6 months, or unless 2, there is some specific reason to question a welder or welder operator's ability. Okay, so as a certification, you have to send in documents to the AWS every 6 months. It's a maintenance form. You got to pay on a fee. It used to be like $15. I don't know if that's still accurate or not, but you had to pay the maintenance fee, and you had to send in this paperwork to the AWS every 6 months saying that, yes, John Doe is welding, doing this type of weld, which is within a certain weld settings and everything. You had to do that every 6 months to show that you were still doing it. Or the other option, option 2 there, is that for some specific reason to question a welder or welder's ability. So if you come in and I'm talking to you, they're doing a job test and everything, and some of your answers don't quite match what you should be doing and everything. Let's say you're doing 70-18 and you say, yeah, I prefer to run it downhill, when it should be running uphill and you're only qualified to run uphill. I got to start reasoning to question that. There is also another clause in there that states that unless also the engineer on the project, or the end user, the end owner of it, that they require them to be certified within a certain time frame. If they require they be certified in the last 6 months, you did it 7 months ago, you have to recertify. If the owner, states that, I want this to be done by certified welders, and you let it slip, you're going to have to recertify. You can't just simply go back, and have that a given time frame. Oh, I'm still good type of thing. So if the end owner, engineer, if they request it, it still needs to be done. Now, not everything requires certified welders, and a lot of people get this mixed up as what certification qualification is. Some companies think, oh, my welders are certified, and they're not really certified, they're just maybe qualified. They may not even be qualified in what they're really welding. Some areas definitely do require it. They will not let you weld if you do not have the paperwork, and it is an actual paperwork card that comes out from the AWS certification. The Iowa DOT is one of those areas now. The DOT requires that you be AWS certified, that if they're coming around and checking it and everything and you do not have that paperwork, they will not let you weld, they will shut you down and everything. Sometimes you might have to be a little watchful because they may not know what positions qualify you to weld, because that card is only going to state that you welded in this position, that you welded in a horizontal position and you're doing some flat welding. They may not realize, well, that also covers you in the flat too. I do know of a case where one inspector tried to shut down a guy. He called up his supervisor and explained it and everything, and the inspector was told, no, that you're mistaken. So that's a certification. A qualification is the exact same test. It's the exact same actual test and everything, and there are several different types of tests, but it can be the same test. It's checked by a CWI, a Certified Welding Inspector, checked to the same parameters, within the same reasons, all looking for the same type of defects and everything. It just does not have that paperwork. It does not specifically, they can't backtrack it. If somebody calls me up and says, did John Doe do it on this type of material, and can you provide documentation? No, I know I can show what material it was, but I cannot prove the chemical composition to that. That's where a lot of that big part of it is. It also does not also sit within this time frame, the 6 months, to having to pay the maintenance fee and everything. It also does not have any of that. You can still go back to the whether or not you believe they're capable of it, their ability of it. You can use that, but I mean, it does not have the time frame stamp on it that the certification has to it. Qualification, certification, it is a one-time test. Okay, it's basically a one-time test unless you fall out within those parameters there. But otherwise, it's considered a one-time test. So that's kind of where that ability falls in. You could have simply purely got lucky on that test when you did that certification. You purely simply got lucky when you did it and have it pass and everything. When you go and do it for a test for somebody and everything, and you might not be able to pass it. It's simply saying that this one time that you did it, you were able to pass it successfully. And it states that in the code book. There are different codes for different materials, whether it's carbon steel, stainless steel, aluminum, whether it's a structural building, whether it's a bridge, whether it's agricultural. They all have different codes, different material thicknesses. Below 1/8 of an inch is considered sheet metal. Above that is considered falling, whether it then be into the structural. The most popular one is like this one here. This is the D1.1, where it's a structural welding code. You can see it's a relatively thick one. It's probably the most common one, and this is the one a lot of people reference to, whether or not they even really should. I know some companies that build items that are traveling down the road, whether it be trailers, whether it be attachments on trucks and things like that, and they'll qualify their guys to D1.1. D1.1 is structural. That means buildings and things like that. Whereas they are probably more apt into either a, sometimes it could be an agricultural one, or maybe it could be like earth moving. There's another one for that one. So that is, but the D1.1 is the most common one. And a lot of things transfer from one to the other one. The bridge code one and the D1.1. The plates are essentially the same. The plates are the same, the setup is the same. The only difference is that the amount of height the B can be above the plate. For one, the bridge one is a little bit taller than the actual D1.1. It's a little bit taller. The other major difference is the the bridge code one states you cannot use power tools. You cannot use a grinder. You cannot use a power brush. It is a chip and hammer, a wire brush, a pick, chisel, anything along those lines, but it cannot be a power tool. I know out in the job site they do allow some of those use and everything, but on the test itself, you are not allowed to do it. Whereas D1.1, you are allowed to do that. You can go, and if you lay a bad bead in there, you can go and grind it out. Now grind it out, but you cannot leave grind marks that are visible to the final project. That's a big difference between just saying grinding it and fixing a bead. If you go and grind that thing and it goes and makes a big old groove outside the weld zone, that's going to fail. If you go and grind it and you weld a bead over top of it in the end, so you can't really tell that you did any grinding, that's acceptable. That's one thing in the D1.1. Okay, so I mentioned as far as WPS PQRs. A PQR is a performance qualification record. A WPS is a welder procedure specification. Okay, so what that really means is, my best example I use with students is making a chocolate cake. Okay, as far as making a chocolate cake, if I ask a student to make a chocolate cake, they would tell me, I can't out of the box. Okay, why can you do it out of the box? Well, it tells me how to do it. That's what WPS is. It tells me exactly how to do it. This is going to, say for GMAW, it's going to tell me how much wire, how much voltage, how much gas, what my flow rate of my gas should be, type of gas. It can tell me the nozzle diameter, maybe that's specific to this one weld. It can tell me my travel angle, my work angle, my travel speed, and it can tell me anything else that I might need to do this weld. And this is going to be specific to a certain type of weld. This is not just general overall, this is specific to this one. Because that chocolate cake is maybe not the same, it's not going to be the same as angel food cake. I got to do a different process to get that one. So I can't use the same instructions. Okay? A strawberry cake and a chocolate cake, yeah, maybe they are the same and everything. So it's going to apply to certain items. Okay? But it tells me how to do it. Okay, so how did they get to that point? How did Betty Crocker decide that I'm going to use 2 eggs in this and not 3? That I want the oven to 350, not 375 or 400. How many minutes to run? Okay, that's a performance qualification. Okay, so basically you ran a series of tests over and over and over again to determine that I am going to get a sound quality weld every time. Okay, so they went and Betty Crocker ran that test. She did 2 eggs. They tested it, they tasted all that fun stuff. Yep, it's pretty good. Well, what happens if we add another half a cup of sugar? Okay, there's another test. No, it's too sweet and everything. Nope, we don't do that. What happens if I raise the cooking time, from 20 minutes to 25 minutes? Oh, it burnt the bottom. Nope, not going to do that. What if I drop it down and try and make it more moist? Oh, now it's too gooey, it's not done enough and everything. So basically they did a series of tests over and over again to determine what was going to be a good product. Okay, that's the performance qualification record. A series of tests that's going to show, yes, I can do it each time. Then you take those instructions, you make a WPS so that somebody can do it. Okay, then you actually have the qualifications and certifications. Okay, to basically see that you as a welder are able to follow these instructions and make a sound quality weld. That's your certification qualification. Okay, my daughter, if I go and have my 7-year-old go and make that chocolate cake, is she going to have the same result as me? No, she's not going to be able to follow those instructions the same. She's going to either add too much milk because she doesn't know quite how to measure it, or she's going to not mix it thoroughly. Things like that. You can still have all these things and screw it up. The idea is that they are all consistent, so that if I have 25 students making chocolate cake for me, theoretically I should have 25 that are good, within reason there. I might have some students qualifying wise that may not be able to do it. So that's where this whole idea comes in. And like I said, this book basically tells you all the rules that you can and cannot do. So if I got one student that decides, I'm going to run higher or something like that, run more wire and everything, okay, well now you start changing some of that. They actually state in here how much of that, once you do that qualification, how much can you change within reason, okay? You have to obviously do a test, okay, do the weld to see if you can do it. So the way that the welds work, turn to the right page here. So basically, you can certify, qualify into certain positions. Okay, so if I'm doing a plate is probably the most common one, a 3/8 V-groove plate. I'm going to show you guys how to do one, how to weld it, how to set it up. That's probably the most common one because a plate V-groove also covers a fillet weld. A fillet weld does not cover a plate. Okay, so as I look at my book here, and I'll do a screenshot of this, my 1G, it tells me my 1G position, so that is a flat. 1 is flat, G is groove. It tells me that I have CJP and a PJP. CJP is complete joint penetration. PJP is a partial groove, partial joint penetration. Then I got fillets, I got butts in here. It tells me if I do a 1G position that I am good for a flat, for a partial, for the groove. The fillet weld, I'm good for flat and horizontal. If I go and do a vertical one, okay, I do a 3G. That tells me I'm good for flat, horizontal, and vertical for my fillets, for my grooves there. But if I go to 4G, my overhead, now I'm only good for flat and overhead. It does not cover me for horizontal and vertical. Why is that? Well, that's because it's not the same process. I am not going to use the same manipulation of it. Okay? I've got to move my torch differently as I go across that plate. I'm doing that vertical weld. I'm going to have to do a slight side-to-side motion, maybe a triangle shaped motion there so I can get that penetration. Overhead, I can simply run a straight bead to it. So it's not the same process. I can do a 3 and a 4, and that will cover me for all positions. Okay, so I can do that one, but that's 2 plates. And when you do the plates, they are going to cost you. Okay, now it's going to depend on the CWI or the ATF, whatever they want to charge you. You are going to have a fee to the AWS. It's a flat fee. That's a processing fee. You're going to have that, plus you're going to have whatever the testing facility wants to charge you. Whether it be a flat rate of call it $200 per plate. Okay, some might be it's $100 a plate plus $50 an hour for actual time and everything. Okay, so each time you do one of those plates, you're going to have that cost. Now, a lot of people think, oh, I want to get certified or qualified in SMAW, GMAW, 3 and 4G. Okay, that's 4 plates. That's 4 plates you're going to qualify in. If it's, say, $200 a plate, that's $800. You go and get a job. You're doing a MIG welding job and everything. You went and did it to D1.1. You go and get it for Vermeer Manufacturing, which is making earth-moving equipment or agricultural. Your $800 you just spent getting D1.1 just went out the window because that certification does not cover what you're welding over there. Now, it may help you get in the door. It may help you go and get in the door, move your resume to the top of the list and everything. I won't say that it will or will not do that, but they're probably going to have you test again. Back to that, if you want to question their ability, you have every right. They have every right to do so. They're probably going to have you test again, to see whether or not you can do it. But that certification qualification, like I said, you just spent $800, maybe more, maybe less, all just went out the window. Or you go and get a job TIG welding. All out the window. Or type of materials, type of wire. You do it here, we run 035 wire. You go down to Bauer Built, we run an 052 wire. That's not covered. You're not covered on that. So back out the window. Like I said, it might move you up the list. That may be. Now, for how the test is going to go. Okay, basically the test is just a simple weld test. You're going to weld across the plate there. Then what they do is a visual test on it. They look for the height. Okay, it is only allowed to be so tall above the plate. They're going to look for, is it below the plate? It cannot be below the plate. They're going to look for, obviously, porosity. They are going to look for that it's fully filled in. It's very simple. They're going to look. I look for grind marks. I look for grind marks, and I look for the edge of the V groove. Because those 2 things right there, those are the quickest 2 things when I do them as far as rejecting. If you got a grind mark outside the weld zone, that's done. If I can see the edge of that V groove, the top edge of that V groove, that's done, because that means you didn't fully fill it in. So those are the two biggest things I fail on for the visual part of the test. What they'll then do is, most common one, now this kind of depends on facility that's testing it. They can either do a bend test or they can do an x-ray, okay? A bend test, they will cut strips out of there. They will cut strips out of there and they will do a bend. Whether they do a face bend or they do a side bend, it's kind of up to the company. There are certain rules in here that state whether or not you can do what. I typically prefer to do a side bend just because it takes a little less time. You can also do an x-ray. Just like if you ever seen an x-ray for an arm or had one done, it's very much the same process. They run it through the machine. It can tell the density of the welds because they are all different dense than the base metal. If you have something like porosity, it's a hole. It's obviously not dense. Porosity, things like that, they will show up. Things like wagon tracks, lack of fusion, all those things show up. I'll throw in a little bit of video or a little still shots so you can see some of those items. All right, so we're going to go ahead and cut our parts here. We are going to run with a 1/4 inch root opening, so that is going to put our angle of our bevel to 22.5 degrees. Since we're doing a 1/4 inch root opening, that calls for a 45-degree groove angle, so 22.5 for each of the plates there. That can vary. If I run a larger root opening, a 3/8 root opening, I actually bring that down to 30 degrees. It's going to make a smaller groove opening. It all depends on which of those qualifications you're running to, which of the pre-qualified WPSs. So the one that we run, like I said, is going to have the 1/4 inch root opening. So I've got a 3/8 plate here, because as we run our plates, it runs to twice the metal thickness we qualified. I run 3/8 plate, I'm good up to 3/4 of an inch. If I had 3/4 of an inch, I'm up to 1.5 inches. If I run a 1-inch plate, then I'm considered unlimited on my metal thickness. And then my procedure is my qualification certification is going to be good from 1/8 of an inch on up to twice that metal thickness. So like in this case here, we're going to run 3/8, that's going to make it 3/4 of an inch. Okay, so to set up my cut, I'm going to turn my track torch on. I'm going to go through, this is my on, off, kind of my free wheel. This one here is my forward, neutral, reverse. And this knob here is going to be my speed. For this 3/8, I like to run 18 inches a minute there. I think that gives it a good speed, gives me a pretty good cut that I'm happy with. One thing I want to do is I kind of like to take a brush off this track a little bit, because it kind of gathers a little junk on it over time there. And if I start getting a bunch of little specks on there, well, my torch is going to bounce a little bit. And I don't want that on my finished cut. Setting up my gases, I'm going to turn on my oxygen gas. The tank goes all the way. My acetylene, I'm going to turn it on about 1 turn. I'm going to check my actual working pressure. So my oxygen, I'm going to set it to 45 psi. And I'm going to set my acetylene to about 7 psi. Okay. Now on my torch here, this knob is going to adjust whether that moves the torch in or out. And I've got a knob here that's going to adjust my torch up and down. Now I've got 2 more knobs on the back side here. Those you shouldn't have to mess with. What that's going to do is change the angle and my direction of travel, my travel angle, and my work angle. Since I've already pretty much got this preset to about 22.5 degrees, we don't need to mess with those. Now my plates, I said, are 3/8 thick. They are about 2.5 inches wide, a little wider than we normally run for our joints, but that is because I'm going to cut off a little bit. Okay, if I made them 2 inches, cut off a little bit, now they're going to be a little bit harder when I do a bend test later. So I like to make them about 2.5 to start with. They're about 5 inches wide. We run 5 inches wide just because, you know, your skill ability, whether it's 5 inches or 7 inches, it's going to be about the same. It's still getting that motion down. This way we get a few more pieces out of it. Now, when you do an actual qualification, okay, an actual qualification is going to call this plate as a finished plate to be 7 inches. Okay, that means when I go and do it for a company or an individual, I actually make my plate 8 inches. That way, when I have a little bit of on time and off time, and I will show that when I set it up and everything. Okay, so I'm going to bring my torch over here. I'm going to crack my settling. I'm going to set a neutral flame. Alright, so I'm going to go ahead and light my torch. I'm going to crack open my acetylene. I'm setting it to a neutral flame. I'm going to move it up onto my plate. Adjust it in and out so that I'm on my plate. Adjust my height, so I'm just got those preheats just off the base metal. I'm going to hit the, while off the plate, I'm going to hit the cutting bar. I may have to adjust the height of it as it's going across. The table's not quite as level as the track torch itself is. I'm done. I'll bring this back, shut off my torch, shut my tanks down, lead out my lines. Now these are going to be hot, so I want to either use my pliers, something like that, to lift them up. Here in a minute, we'll look at them and see as far as what additional cleanup we need to do. Alright, so now that my plates have cooled, I'm going to go ahead and prep them. I want to get rid of this oxidation here. I want to get rid of this dross on the back side here. I got two different options in stones here. Now I got my regular grinding stone and I got my flat disc. This grinding stone is great for if you want to remove a weld. Okay, you want to remove a lot of material, this is the one to go. I want to do just some cleaning to it. So I want to use this flat disc. Basically, it's like sandpaper that's all glued onto here. I'm not looking to remove material, a lot of material like a weld or something like that. Maybe I could use this to, remove a little bit of height or something like that, but I wanted more of a smooth finish. This one's going to be a rough finish. Okay? Whether you want to clamp it to the table, clamp it on a piece here, vice, whatever, it's kind of up to you. Now, I only did just a little bit on this edge here. Like I said earlier, about as far as if you go and grind the material here, that's a fail. Now there's a fine line between grinding it, when you gouge into it, versus I'm removing a little of the oxide here. Otherwise I didn't gouge into it. I also wanted to hit this backside here because when I run this bead, I'm going to have to burn through this plate. And I want to make sure, I want to kind of get rid of some of this oxide formation here. I don't want that potentially to get in my weld, potentially cause a defect. Can I get away with leaving it? Yeah, I probably can. Do I want to take the chance that it's going to fail as a result of leaving it? Probably not, when it's going to take me all of 5 seconds to hit that quick with a grinder, get it removed there, and not have to take that chance. Now, I also like to do a long sweep motion to it, like this. I don't like to do just little things here, because then I'm not going to have a nice consistent in my grinding. This way I'm a little bit more consistent. If I go and do like here, and I do a portion here, did I do it just as much, just as deep? Maybe, maybe not. I like to do a nice long sweep there. Also, especially when I'm using the sander there, or even the grinder, probably more with the grinder. That way I got more consistency in my finish there. If I'm using a grinder, I'm not going to press heavy on it, just letting that disc just barely rub on it so that I can clean that piece up. By the code book there, for the one we're working on, it basically says that it needs to be 1/4 of an inch up to 3/8 of an inch thick for the thickness. For the width of it, it's minimum of 1 inch if it's going to be a bend test. If it's going to be an RT test, then it needs to be 3 inches wide. What I'm going to do is I'm also going to go and sand this down so I get the mill scale off. Same idea as the backing there, just so that I decrease the chance that I'm going to have a defect. Maybe a little bit more important if I do a bend an X-ray test versus a bend test, but we're going to go ahead and do it for good practice. For the length of this, I cut this 7 inches. I just grabbed something that was in stock there. And when you guys are in class, you can do it to 5 inches. We're going to put a piece on the end here. But generally, I like to have a little bit more here and here. That way, when I start welding, I start out here and I can burn into it and then exit here. That way, my gun, if I'm getting that kind of little popping and everything, when they starting, I'm not going to have that in my weld here. I'm going to have it on this plate here. This is going to be scrap anyways. So here, I just sanded down, stripped down through the center there. I didn't have to worry about getting every single little piece. I didn't worry about getting out here because that's not going to matter. My weld is going to be right through the center here. One thing I try to avoid is any gouges in there. That can make it a lot harder on your plate when you're trying to burn it in. That can give you a fail, and kind of like a false positive type thing. So I don't want any gouges in there, so I try to use longer motion type going across there. So now we're going to go ahead and start tacking things up. All right, so now I'm going to go ahead and tack my parts together. And it really doesn't matter whether they are in line, not in line. I mean, it doesn't really matter a whole lot. There's only certain things that really will come into play. One, I'm going to make sure that this is down tight. So I'm going to take my vice grips here. Clamp this thing so that it's good and tight. I don't want a gap or anything like that, because a gap is going to make it so I lose penetration. So I'm going to clamp it down tight like this. I'm going to run a small bead on this side. I'm going to run a small bead on this side here, basically just so I can burn that in so my plate is not going to move on me. Right now, I mean, I've just got to set the pulse. It doesn't matter. I mean, I don't have to have it the same settings as I'm going to weld. I can't change the settings while I'm welding. I should not run one bead with one setting and then change it for another one, just same as my progression on this. But tacks out here, that doesn't matter. So I'm gonna make a weld going across here. Okay, now I'm going to do the same thing on the other side, but I need to have a 1/4 of an inch gap in between here. Okay, so I need a 1/4 of an inch gap between here. So right now I just got 2 plates of 1/8 inch. That's a simple, easy way to do it. Let's just take like either a piece of 1/4. In this case, I used 2 plates of 1/8, stuck it in between there, push it all the way up to it. Clamp my piece down so it's tight. So now my plate is ready, whether I go and do a vertical weld or if I do a horizontal overhead, it really doesn't matter. I mean, basic idea is going to be the same, setting them up with this style. Now remember, that gap can change, this angle thereby can change. But we're going to go ahead and do a vertical weld. So we're going to set it up like this. The length on this end, as far as having them even, as long as they're within reason. I mean, because I'm going to cut off, when I do a full plate, it's 7 inches long. Or it's 8 inches long. This is going to be 8. I only need 7, so 1/2 inch I'm going to cut off. For this one here, for you guys practicing and everything, this is not too. I mean, as long as you eyeball it, that's close enough. So now I'm going to go ahead and get it ready so I can do my vertical weld, so it's comfortable right in front of me.